So it's been a while since I did an update to the Pixel display. And that mostly comes down to me being ridiculously busy and maybe not wanting to solder all the LED strips again. But like all tasks, I rolled up my sleeves and I got to work. And as you can see here, now it's mounted. And I think it's looking pretty good. Well, reasonable enough for what I need anyway. So let's take a journey from the previous prototype video all the way through to the alpha you see here. Let's start with a comparison. Here is the prototype. And here is the alpha. Now, I'm calling it alpha as it isn't something I'm going to take all the way through to a slick production piece. I've just taken it to a level that I can play with it without too much setup, without it looking like something I whipped up in a few minutes with a jigsaw and a couple of pieces of wood. So let's take a look at how the new build came together. I started by deciding to lose the wood backing and go to a 3D printed backing instead. This is for the LED strips to mount on. Now, why I did this? Well, for one, I don't own a CNC machine. Yeah, that's surprising. Don't tell the wife, but websites for CNC machines have been getting frequent visits for me recently, especially after having to do this project. Now, with a circular saw, I can get close with a piece of wood, but it's not accurate enough for my liking. The table saw has just been bought on Prime. Again, don't tell the wife. Now, I also wanted channels for the strips so they could run through and it would make the precision really good on the placement. And I also added notches so the offset grid that I had before can get an exact position on this new layout. Now, after the backing was designed, I looked at the trim that goes around the actual display. Now, annoyingly, and I'll go into this a little bit more detail later, but I got strips that meant that this frame was just beyond my large scale format 3D printer. And I do have a large 3D printer. It's a 1/2 meter by 1/2 meter by 1/2 meter. This is just a little bit too big for that to build a trim in one go. So I had to print them in parts. And a little tip here, if you're printing, make sure you print a small bracket that can actually go between the four corners. Therefore, it locks the trim in place as a well-defined square. Without those, you might get some misaligned corners if you're just trying to butt the actual trim up against each other. Now, next is the rear sheet. Now, as no one would see this apart from me, I basically reduced this print down and just printed it as a support, not a complete sheet, which works out really well for me and saves my print material. And here you can see a small animation of how everything comes together with the clear sheet in front, which I kept from the prototype, just gave it a good cleanup. Now, on that note, if you're interested in how I put the prototype together before I did this alpha version, I will leave a link in the description to the video on that build that you can watch after you finish watching this one. Moving on, we can see from these pictures me soldering the cables to the strips. The data cable zigzags line by line, and if you're taking on a project like this, double check the data cable direction on the strips. More on that later. Now, wiring up these strips, you can't just chuck power in at one end and expect all the LEDs throughout the whole display to be happy with that. You have to insert power part ways along the lines. I chose a power supply with 5 volt and 20 amps. Will that give me the full brightness? No, it won't. However, I had it on spare and it gives me as much brightness as I need. And too much brightness and it blows out the camera anyway. So who needs that? Now, I inserted power at the start and then every 8 strips along, even connecting the last strip, and I will let you judge if that's enough brightness for your project. Just be safe when building these things. Messing up at this stage could result in a new fireplace rather than a new display. You've been warned. And on that point, make sure you're using the right cabling as well. Choosing the wrong rated wire can also result in a burning spell that turns into a search for the nearest fire extinguisher. Now, let's move on to the heart of the build, and that's the controller board. If you watch the prototype build video, nothing has changed here from the ESP32. I just 3D printed a custom case and added a little switch for turning it on and off independently. And I also added a little light to let me know it's running. The controller is now powered from the power supply rather than a USB connection, which it was before, keeping everything a little bit neater. Though it should be noted, I added a hole in the case to get the USB port easily in when I want to reprogram it. You don't want to close it all up and have to reopen it every time you just want to play with it. Now, mounting the display to the wall, I chose to go with a shelf you see here, instead of bolting it in. And again, this is so I could take it apart, move it off, and play with it in the future. A little tip here for when you're mounting a display for your streams, plan ahead of time. Don't just assume that the position you're putting on the wall is going to work. Have your camera running, put some white tape, as you see me doing here, and then make sure you're happy with the actual position it's going to go in. Now, as I stated at the beginning of this video, this is an alpha level build, what I would consider an alpha. I'm not going to take it through to a production level build. Now, I could make the frame better, I could tweak the design, keep going over the electronics, clean up the wiring, but this is as far as I want to go with this project hardware-wise. It's good enough that I can play with software from Unity and other applications and just have things displaying and see how they work, make some games, etc. The hardware is as good as I want to take it. So if I were to do the project over, what would I change? Well, I would buy tighter grouped LEDs, just to reduce the size of the display overall. That way my print area would be smaller and I could print the frame in one go and reduce the amount of time it took to just do this build by quite a considerable amount. Secondly, I would have printed the back for the display prototype. Deciding to change between the wood panel I had for the prototype to the printed option you see here was a real pain. These LED strips do not like being pulled up and put back down. Their stickiness really gets reduced. Luckily, I had the right size double tape on hand, but still, it's just an extra step I didn't need to take. The printed back sheets really gave a really good accuracy to the spacing and a better overall design. Now, what would I recommend if you're thinking of taking on this project? Get a good soldering station and work area. That's my first point. There's a lot of soldering involved in these projects, which can be done on the cheap using a cheap soldering iron, but if you can afford it, splurge out a little and make your life a lot better. A good soldering station is really worth its money. Also, get a little fume station, because your health is important and you don't want to be breathing solder all day. Next, buy the LED strips that meet the size of your 3D printer. I stated it several times during the video, I can't emphasize it enough. Lastly, check and double check your soldering points. Getting this into the frame, mounting it, and then realizing there's a problem is a real pain. Take it off, check your soldering points. Yeah, I did it a few times. Just make sure you get it right. Now, there is also a point that, and I mentioned it during the video, that you want to make sure the direction of your strips is actually correct. I did actually have to take the whole frame apart once because I thought a cable had come loose, only to realize that I'd actually flipped the frame over from when I plugged it in, because I was building the frame, and plugged in the data cable at the wrong end. So that's an hour of my life I won't get back, and that's an important point for you to take into consideration. Other than that, that's everything I wanted to talk about as far as the hardware is concerned. In a future video, I will put together something that shows how the software works for these particular displays, including the little Unity application I made to run the visuals you see on the display during this video. So if you're interested, make sure you're subscribed so you don't miss out on those. And also, very importantly, if you like this video, hit the like button. And as always, thanks for watching.